Okay, hello everyone and welcome to the class. Today in this session we'll be doing we'll try to look upon the questions which are asked in CSIR-NET based upon your EPR spectroscopy. So what's the benefit of this topic? What is the strategic approach? What kind of questions can be asked from there? So I have taken one questions of each type and we'll be discussing that. Okay, so it won't be a big it won't be a long session. It will be a short session in which we'll just see that how and what kind of questions can be asked from your EPR spectroscopy. All right. So yeah, I guess many of you were waiting for the class. Generally, my class timing is from 12 p.m. to 1 p.m. Okay, on Unacademy. This I used to take on Unacademy, and this is free classes. Okay, these are all free classes. This I am telling for Saturday and Sunday. So just after that, from 1 p.m. the class the class is supposed to be start on this particular platform, but it takes around 10 minutes for all the technical setup and all, right? So it takes around 10 minutes. So generally it starts from 1:10 p.m. and it's around a 30 minutes session on on YouTube platform. Okay, so yeah, this is how it is done. Fine. So let's start with it. So first of all, in order for a particular molecule to be EPR active, okay, so you should know about that as well. That actually what EPR spectroscopy is, this is called as electron pair repulsion spectroscopy. Okay, there is also one more name of it called as ESR, where we take electron spin repulsion, and that's what it is. So the concept is that if a particular molecule has unpaired electrons, so it will have a particular spin. Okay, so a unpaired electron is like this is the condition. Okay, what is the condition or the requirement for this EPR spectroscopy? That you should have unpaired electron. Okay, unpaired electron in the molecule. Now what does this unpaired electron will do? Unpaired electron spins on its own axis. So if this is an unpaired electron, it will spin. If this is the axis, so it will spin around it. Okay, it will have a certain spin, and due to this spin motion, it will create a magnetic moment in itself. Okay, so that's called a spin only magnetic moment. Okay, so there will be a spin only magnetic moment. So a tiny electron can behave as a magnet in its own. So electron can behave as a magnet in its own because of its spin motion. Now what happens if you put this particular electron in the external magnetic field? Good afternoon Gayatri, hi Teja, hello. So if you put it in external magnetic field, so let's say if all the electrons are like this, okay, all these electrons have random spins in random magnetic moments in different directions. So when you put it in external magnetic field, so what happens all of them are going to assign themselves according to the external magnetic field. This is what you might have studied as a property of paramagnetic substances also. So they assign themselves in the direction of your external magnetic field. Now there can be two types of alignment in which they can assign. Either if your external magnetic field is applied in this direction, let's say this is the direction of external magnetic field, so they might align themselves according to this, or they might align themselves in the reverse direction. Okay, so these are called as the alignment along the direction of field, and this is called as alignment in the reverse of the direction of the field. So this is the principle, and this is what you all should know. That's how the EPR spectroscopy is made. Now once we have got these two states, let's call these states as alpha and beta state. So the principle is quite similar to the NMR spectroscopy. I know most of you have studied that. So that means in the presence of external magnetic field, the electronic states or electronic spin states are going to get converted into two states, they are going to make two energy levels, alpha level and beta level. Now what you do, you make external factors like your some radio waves or some waves which falls on these electrons, and when they fall, they try to make the resonance between the two states. Okay, so that's the resonance is where you will get your spectroscopy from. Okay, so this is all the principle about it. But what are the conditions? The condition is that you should have unpaired electrons. Now if you have unpaired electron, this also you should know that in how many energy levels a particular level is going to split. So for that we have a rule called as your spin multiple, that is called as your That rule is going to tell you that in how many lines a particular energy level is going to split. Okay, so that rule follows 2ni plus 1 formula, where I depends upon the nuclear spin of the neighboring atoms. For example, if I have CH3 radical, okay, now this is a methyl radical in which I have one unpaired electron which is there on the carbon atom. Now remember this, that carbon has this unpaired electron. So this particular unpaired electron is not going to, it is now, right now it is just having a single energy level. It is not splitting in any other energy level, it just has a single energy level. Now what happens, that since you have 3 hydrogens which are attached on this particular carbon, and all these hydrogens have different I value or have different nuclear spin values. So using this formula, how many states we will have? 2 into n. N is the number of hydrogens. We have 3 hydrogen, I value of hydrogen is half and plus 1. So if you calculate this, you will get 4. So that means this single energy state of carbon atom, carbon electron basically, is going to get split into 4 energy levels by your hydrogen electrons, okay, or sorry, by the hydrogen atom. So this is called as your fine splitting, okay, the one which is done just by the adjacent atom. So there are different types of splitting which is there. One is called as fine splitting, one is called as hyperfine splitting. So we'll just look upon that. Generally questions are asked from these topics only. Okay, so let's take this first question over here in this class. This says ki the total number of hyperfine lines in the EPR spectrum of one electron reduced product of this. This is the molecule given to you. It's given ki CO3 and you have CO, that is carbonyl whole 9, and then you have Se. One electron reduced product it is. Okay, and it's given ki I value for your cobalt is 7 by 2. Okay, that's what is given to you. Now this is the organometallic fragment. First of all, you should know ki what will be the structure of this. Now if you draw the structure of this particular molecule, you will find ki your cobalt, there will be 3 metal bonds in this case. Okay, so your cobalt is going to be fine. You have to first of all find out the structure of this. Okay, so that you can do by calculating the total number of valence electron, and by doing so, so total valence electrons will be how much in this case? So cobalt is going to give you 9 electrons, 9 into 3 plus 9 into 2, because each carbonyl is going to give you 2 electrons. Now this selenium goes in oxygen family, so it is going to give you how many electrons to the state, like just like your oxygen gives you 2 electron, sulfur gives 2 electrons, so selenium should also give you 2 electron. If you calculate the total valence electron, you will get how many? 27 plus 18 plus 2. So this is going to give you, sorry, selenium is going to give you, I guess, should give you 3 electrons. Okay, so 27, and then if you add 18 to that, and if you add 2 more, so it becomes 47. It should be 48, because in that case you won't get that, right? Fine. Once you have got, and it says now it's 1 electron reduced. So 1 electron, just let's reduce 1 electron, sorry, 1 electron reduced product. So let's reduce one of the electron from here. So you have how much? So 46. Now just calculate the total number of valence metal bonds. So metal bond is calculated like 18 into n minus this 46 divided by 2. So 54 minus 46 is going to give you 8 by 2 is 4. So you'll have 4 metal bonds. So just try to draw this. Okay, 1 electron reduced product it is, right? 1 electron reduced means it is reduced by, sorry, I am doing a mistake here. 1 electron reduced means you are reducing the complex by 1 electron. So that means reduction is, you have to see. Okay, so you have added 1 electron in this case. Okay, and it should become 48, and if you do that, you will get 3. Okay, so 3 metal bonds. Draw the structure of this. So the structure will be like this, CO will be attached with CO like this. Okay, and then you will be having like all these cobalt, like carbonyl groups like that, and this selenide will be present as a bridging ligand over here. Fine. So that's one of the other case, but what you have to see is which is EPR active over here. So cobalt being EPR active, so it will split each other like that. Let's try to do it. So the I value for cobalt is 7 by 2. Now if you are talking about one of the cobalt, it is going to split because of the other two cobalts, because they are attached to it each, like they are attached to this. So use this formula 2Ni plus 1, N value will be 2 here. Why? Because one of the cobalt is attached to two different cobalts. I value is 7 by 2 and plus 1. If you do that, so how much will get? 14 plus 1, 15. So your answer should be 15 in this case. Okay. So hyperfine lines in this case will be 15. That's what you will get for this particular molecule. Okay. For the next question, if you look upon the next one, which says that which of the following species is ESR active. So this question I am giving homework for you all. Okay, you guys can do. What you have to do, you have to just look upon for the oxidation state of the metal in this case, and you have to tell ki which of them has unpaired electron. You have to look for that, and the one which has unpaired electron, that will be done. प्रीति देखो, वन इलेक्ट्रॉन रिड्यूस्ड प्रोडक्ट का मतलब क्या है कि ये मॉलिक्यूल था, इससे एक इलेक्ट्रॉन रिड्यूस्ड, ऑक्सीडाइज्ड एंड रिड्यूस्ड, यू नो दैट राइट. So one electron reduced means it is reduced with respect to one electron. So that's why when you are counting the total valence electron which came up till here, since it is one electron reduced, that means there is reduction which is caused because of one electron. एक electron का reduction मतलब you have to add one electron more. इसीलिए I have added one more here. ठीक है, एक electron इसीलिए हमने add किया. That's why it became 48, and when you solve you will get 3 metal bonds. ठीक है, तो यहाँ पर I have got 3 metal bonds, and that's how the complex is. ठीक है, so it's just based upon the language of the question. Clear है? ये वाला जो part है that you guys have to do, you guys have to tell me कि how it will be done. Like ESR active, options are A, B, C and D. So whosoever is there in the class, just try it. Okay, just look upon the oxidation state of these species and tell me कि which is going to be the correct product. Okay, so I guess this one you guys will be able to do. I'll take some different types of questions which are asked on the basis of this ESR or EPR spectroscopy. The next question says ki total number of fine and hyperfine lines, hyperfine EPR lines expected for octahedral high spin Mn2 complex are. Okay, they have to tell total number of fine and hyperfine both lines for octahedral high spin Mn plus 2 complex. Okay, the I value is given to us as 5 by 2. So I value is given to us 5 by 2 and it's a octahedral complex. So octahedral complex का मतलब है you have D5 species. D5 means how many unpaired electrons do you have? Unpaired electrons कितने हैं यहाँ पर? So unpaired electrons is 5, right? You have 5 unpaired electrons in this case. High spin complex है. So let's find out first of all fine lines. So it's not given about anything about this particular complex कि इसमें और क्या है, what ligands you have and what other things you have. We are not at all aware about that. The only thing which we know is that it's a high spin octahedral complex and in plus 2 state. Chalo, so first thing which we'll do is we will find out the fine lines. So fine lines is the splitting caused by the element itself, जो खुद से खुद को split कर ले, that is, or you can say the first splitting which caused is called as fine lines. So manganese having I value 5 by 2 is going to split by this formula. So 2Ni plus 1 will be the formula. Since you have just one manganese in the complex, I value is taken to be 5 by 2, which is given to you in the question, and plus 1. So how many lines do you get in this case? How many lines? Okay, just a minute. You are just supposed to get, sorry, it will not be written like this. It won't be done in that way. Okay, 1 minute. Since it says ki total number of fine and hyperfine lines, right? Fine and hyperfine lines is what you have to tell. So first thing is you have to look upon ki if this is a D5 species, so how many fine lines you can do in this case. Okay, how many transitions you can make in this particular case. इस तरीके से how many transitions you guys will be able to do. Just try to look upon and tell me ki how many fine lines you will be able to get. Okay, so you have this manganese in plus 2 state, ठीक है, D5 species. नेट का एग्ज़ाम देने के लिए पीजी में कितने मार्क्स होने चाहिए? पीजी में अराउंड 55% प्लस होना चाहिए, ठीक है, मोर देन 55%. I guess that's mentioned in your brochure एक बार इसको देख लेना, ठीक है, वेदर चेंज हुआ है या नहीं, बट आई गेस इट शुड बी दैट ओनली, ठीक है, या ओके फाइन. Yeah. Okay, let's go for this. It says ki total number of fine and hyperfine lines, that's what we were doing. So 5 unpaired electrons we have, na? We have 5 unpaired electrons. Remember this, that each electron, okay, each electron is going to split into how many lines? First of all, let's calculate that. Okay, so for one electron, what will be the splitting caused? So for one electron, this is going to cause splitting according to this formula, 2Ni plus 1. Use this. So 2 into, just for one electron I am calculating, okay. So 1, I value is 5 by 2 and plus 1. So that is going to give me 6 lines. So one electron will give you 6 lines. You have 5 electrons. So total lines to 5 electrons. So total lines तो तुम calculate कर सकते हो. That is pretty simple to do. ठीक है. हाँ जितेंद्र, हिंदी में भी आता है, हिंदी इंग्लिश तुम्हारे ऊपर है. इफ़ यू चूज हिंदी एज अ लैंग्वेज. लुक अपॉन इट, ध्यान से देखना. मैंगनीज +2 कॉम्प्लेक्स है. सबसे पहले क्या होगा, सिंस इट हैज़ 5 अनपेयर्ड इलेक्ट्रॉन, क्योंकि 5 अनपेयर्ड इलेक्ट्रॉन है, तो स्टार्टिंग में ही इसकी जो स्प्लिटिंग होगी दैट विल बी डन इन 5 लाइन्स. ओके, वो 5 लाइन्स में स्प्लिट हो जाएगा स्टार्टिंग में ही. ओके, वाई? बिकॉज ऑफ द 5 अनपेयर्ड इलेक्ट्रॉन्स. 5 अनपेयर्ड इलेक्ट्रॉन्स है, राइट. So all the 5 unpaired electrons are going to split into 5 different lines. So these lines are called as fine lines. Okay, क्या बोलेंगे इनको? Fine lines बोलेंगे. Now once you are done with this fine lines, जब एक बार तुम देख लिए कि fine lines क्या है, now hyperfine lines will be the splitting of these fine lines further. तो एक इलेक्ट्रॉन से कितनी लाइन मिलेगी? 6 lines. तो पर इलेक्ट्रॉन you will get 6 lines, ठीक है. Total 6 lines is what you will be getting in this case. Okay, just a minute, I am getting a call, I'll just be back, 1 minute. Okay, yeah, sorry, it was just a random call. So fine, we have 6 lines per each electron. Okay, so each electron is going to give you 6 lines. तो इसी तरीके से ये सब जो होंगे दे आर गोइंग टू स्प्लिट इनटू 6 लाइंस. ठीक है, सब के सब 6 लाइंस में स्प्लिट हो जाएंगे. समझ रहे हो? तो टोटल कितनी लाइंस मिल गई? एंड दीज लाइंस विल बी कॉल्ड एज योर हाइपर फाइन लाइंस. सो टोटल लाइंस कितनी हो गई हाइपर फाइन लाइंस अगर मैं पूछूं तो? सो दे विल बी डन लाइक 5 into 6, दैट मीन्स 30. सो 30 हाइपर लाइंस, हाइपर फाइन लाइंस. और फाइन लाइंस कितनी हो गई? These are just 5. ठीक है, so 5 and 30. Okay, so option number C is the correct. ठीक है. या क्या हो गया जितेंद्र? यू आर इन लास्ट पीजी लास्ट ईयर. यार ये सारे टॉपिक्स तुम्हारे पीजी के ही हैं. ठीक है, ये सारे टॉपिक्स तुम्हारे पोस्ट ग्रेजुएट लास्ट ईयर के ही हैं. और अभी CSIR-NET एग्ज़ाम बहुत पास है. सो द मेन फोकस इज ऑन CSIR-NET एग्ज़ाम. ठीक है, तो अभी मेन प्रायोरिटी CSIR-NET एग्जाम है. ऑलराइट, सो या ऑप्शन सी इज करेक्ट. दिस इज हाउ वी अप्रोच दिस टाइप्स ऑफ क्वेश्चंस. नेक्स्ट पे चलते हैं, नेक्स्ट क्वेश्चन देखते हैं. ओके, इन दिस क्वेश्चन इट सेज कि इन द EPR स्पेक्ट्रम ऑफ टेट्रागोनल कॉपर 2 कॉम्प्लेक्स व्हेन G, yes yes yes, the fine lines will be equal to the number of unpaired electrons here. ठीक है अर्नब? या so fine lines, because you have 5 electrons, so obviously 5 splitting will be already done. Fine lines is like before causing any further splitting, the first splitting which is done is called as fine splittings. ठीक है, तो पहली बार ये 5 लाइन्स में स्प्लिट होगा because of unpaired electrons. Everywhere this is not true that every time fine lines will be equal to number of unpaired electrons. Sometimes fine lines is also equal to the splitting caused by the element itself, and then the further splitting is called as hyperfine lines. For example, अगर मैं ये complex ले लूँ, like if I take this complex, let's say that I have some complex, some hydride MH4. okay, I have some metal hydride और किस फाइबर से लाइव स्ट्रीम करता हूँ? राजन, यहाँ पर एक लोकल प्रोवाइडर है जो फाइबर से लाइक ब्रॉडबैंड जिन्होंने मुझे प्रोवाइड किया है, ठीक है। तो इट्स नॉट एयरटेल एक्सिस स्ट्रीम या एयरटेल 4G स्ट्रीम, कोई ब्रांडेड नहीं है, ओशन ब्रॉडबैंड करके है जो हमारे लोकल प्रोवाइडर है इस एरिया में, ठीक है। अभी मैं घर पर हूँ तो मैं इस ब्रॉडबैंड पे हूँ, जब मैं अपने यूनिवर्सिटी में होता हूँ तो यूनिवर्सिटी का खुद का दिया हुआ जो ब्रॉडबैंड कनेक्शन उस पर, ठीक है। मिनिमम स्पीड तुम्हारी मिनिमम 10 Mbps होनी चाहिए फॉर फ्लॉलेस ऑनलाइन क्लासेस, ठीक है। तो अगर तुम्हें क्लास लेनी तो 10 Mbps की स्पीड होनी चाहिए मिनिमम, 10 Mbps की डाउनलोड एंड अपलोड दोनों स्पीड, आई एम नॉट टॉकिंग अबाउट ओनली डाउनलोड, ठीक है। दोनों 10 Mbps होनी चाहिए कम से कम। okay fine, so if let's say this is a complex MH4 type and M की जो I वैल्यू है let's say is 3/2, ठीक है। तो इसमें जो फाइन लाइंस होंगी वो M के साथ जो स्प्लिटिंग होगी, यानी मेटल जो स्प्लिटिंग करेगा दैट विल बी फाइन लाइंस। तो 4 फाइन लाइंस आएगी, और हाइपर फाइन लाइंस कौन सी होगी, फर्दर जो हाइड्रोजन उसको स्प्लिट कर रहा है। सो हाइड्रोजन विल स्प्लिट इट इनटू 2 लाइंस फर्दर, सो हाइपर फाइन्स कितनी हो जाएंगी, हर एक लाइन 2-2 में स्प्लिट हो जाएगी। तो हाइपर फाइन मिलेगी तुम्हें 4 × 2 दैट इज 8 लाइन्स। सो 8 हाइपर फाइन्स और 4 फाइन लाइन होंगी, ठीक है। बट हाँ, कभी भी नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स आते हैं तो वो तुम्हारे लाइक दैट विल बी योर फाइन लाइन्स, ठीक है। अच्छा ठीक है जितेंद्र, फाइन। इस वाले क्वेश्चन को देखते हैं, लेट्स लुक अपॉन दिस। इट सेज कि इन द ईपीआर स्पेक्ट्रम ऑफ टेट्रागोनल कॉम्प्लेक्स व्हेन G पैरेलल इज ग्रेटर देन G परपेंडिकुलर एंड इट्स ग्रेटर देन GE, द अनपेयर्ड इलेक्ट्रॉन्स रिसाइड्स इन द ऑर्बिटल, ठीक है। तो वेयर डज योर अनपेयर्ड इलेक्ट्रॉन रिसाइड्स, दैट्स व्हाट इज द क्वेश्चन। सो सबसे पहली चीज यू हैव टू लुक फॉर दिस पर्टिकुलर कंसेप्ट, ओके। इफ यू हैव G पैरेलल ग्रेटर देन G परपेंडिकुलर, व्हाट डज इट मीन्स, इट मीन्स यू हैव more electron density, okay, along z axis, ठीक है। तो z axis के along you have more electron density, that means ये कैसा कॉम्प्लेक्स होगा, अगर तुम्हारे पास टेट्रागोनल कॉम्प्लेक्स है। तो टेट्रागोनल दो तरीके से होते हैं, इधर इट इज टेट्रागोनल कंप्रेस्ड और टेट्रागोनल इलोंगेटेड, ठीक है। दो तरीके के कॉम्प्लेक्स होते हैं। सिंस G पैरेलल इज ग्रेटर देन G परपेंडिकुलर, सो मोर इलेक्ट्रॉन इज अलोंग द z एक्सिस। इफ देयर आर मोर इलेक्ट्रॉन अलोंग द z एक्सिस तो क्या होता है, देयर इज अ z आउट काइंड ऑफ कॉम्प्लेक्स। तो कैसा कॉम्प्लेक्स बनेगा, z आउट कॉम्प्लेक्स, ठीक है। z आउट कॉम्प्लेक्स बनेगा। एंड इफ इट इज अ z आउट कॉम्प्लेक्स, इसको बोलते हैं हम क्या, टेट्रागोनल इलोंगेटेड, ठीक है, टेट्रागोनल इलोंगेटेड, यस। और अगर ये टेट्रागोनल इलोंगेटेड है तो इलेक्ट्रॉन की लाइक द d ऑर्बिटल स्प्लिटिंग इज डन इन दिस वे, dx स्क्वायर y स्क्वायर हैज हाईएस्ट एनर्जी, dz स्क्वायर हैज लोअर एनर्जी, उसके बाद आता है dxy और लोएस्ट एनर्जी होती है dxz एंड dyz की। दिस इज हाउ स्प्लिटिंग इज डन इन द z आउट कॉम्प्लेक्स। लेट्स फिल द इलेक्ट्रॉन, कॉपर +2 है मतलब कि d9 स्पीशीज है। लेट्स फिल 9 इलेक्ट्रॉन, सो 1 2 3 4 5 6 7 8 एंड 9। तो अनपेयर्ड इलेक्ट्रॉन कहाँ चला गया, योर अनपेयर्ड इलेक्ट्रॉन वेंट टू dx स्क्वायर y स्क्वायर। तो ये कंसेप्ट है। इस तरह के क्वेश्चन बहुत बार आए हैं CSIR-NET एग्जाम में। तुम्हें क्या ध्यान रखना है कि G पैरेलल और G परपेंडिकुलर क्या बताता है। आई हैव मेड अ वीडियो ऑन EPR स्पेक्ट्रोस्कोपी, वो तुम्हें मेरे चैनल पे मिल जाएगा, ठीक है। मेरा जो खुद का चैनल है, आई गेस मोस्ट ऑफ यू नो दैट, जिन्हें नहीं पता यू गैस कैन गो एंड सब्सक्राइब टू दैट। उस चैनल का नाम है ऑल अबाउट केमिस्ट्री, ठीक है। तो इस पर्टिकुलर चैनल पे लगभग तुम्हारे CSIR-NET के सारे टॉपिक्स लगभग कवर अप हैं, और स्पेशली इनऑर्गेनिक और फिजिकल केमिस्ट्री के। तो तुम्हें ये EPR स्पेक्ट्रोस्कोपी भी उस चैनल पे मिल जाएगा, यू कैन गो देयर, ठीक है। और जितेंद्र, नेट की तैयारी करनी है, इसके बारे में हम लोग बात करेंगे। नेट के एग्ज़ाम हो जाने दो, ठीक है। अभी जो बच्चे ऑलरेडी तैयारी कर रहे हैं, अभी जो बच्चे ऑलरेडी तैयारी कर रहे हैं, अभी उस पर फोकस ज़्यादा है, ठीक है। स्पेशली तुम्हें जो प्रॉब्लम है, आई विल डिस्कस अबाउट दैट जब नेट का एग्ज़ाम हो जाएगा, ठीक है। Actually, I was just answering Jitendra. Okay, fine. So this is my channel. This is my personal channel. You can go over there and you can subscribe to that. There are many videos which are there for your CSIR-NET preparation. You will get a video on your EPR spectroscopy as well over there. If it would be a octahedral complex, if the same molecule would have been for the octahedral complex, in that case it would have been simple, right? In that case G parallel, okay, and G perpendicular would have been same, okay. G parallel and G perpendicular would have been same, and this would have been equal to GE. This is the condition for octahedral complex. And in that case, your unpaired electron will be like that, then you will not be able to tell where the unpaired electron goes, okay. So, and basically, yeah, that's what it is, okay. So, it will be either D8 complex or a D10 complex, तभी बता सकते हो, right. So, that's what is needed over there, okay. So, this is how you have to approach this particular one. Okay, let's go for this one. It was again asked in CSIR-NET June 2011 exam. It says that stark splitting of a given field is larger for a molecule AX as compared to that of molecule BX. Which on the following is true? What is stark splitting? Can anybody tell me? So, stark splitting, that means key splitting is okay, splitting caused in presence of external external electric field, okay, in the presence of external electric field. So, splitting caused in the presence of external electric field. Now, if you have given key splitting, stark splitting is more, okay. So, if I talk about stark splitting, so let's say stark splitting for AX is more than the stark splitting of BX, okay. For EPR spectroscopy, you can follow Dragos, okay. There is a book by Dragos, you can follow that. Yeah, that will help you, okay. That is having good questions from your inorganic spectroscopy. So, EPR, Mossbauer, everything is given in a better way over there. Okay, so stark splitting for AX is greater than that of stark splitting for your BX. Now, stark splitting means the splitting which is caused in the presence of external magnetic field, sorry, external electric field. So, if you have magnetic moment in the molecule, how the magnetic moment is going to affect something in the electric field? You know, according to the Faraday law of electromagnetic, according to the electromagnetic induction, what it says ki if there is a magnetic field associated with a molecule, there will be electric field also associated with that, okay. So, if a molecule has magnetic moment, it will also have dipole in that, okay, electrical dipole also in that. So, now just look upon the questions here, sorry, the options here. So, if the stark splitting is more over here, that means ki there is more like there is more amount of your magnetic moment in this case, okay. So, that's how you can just approach it. So, since you have more stark splitting happening in this case, so magnetic moment for your AX will be greater than the magnetic moment for your BX, okay. So, that's how it will be, and your option number B will be your correct option for this course, for this particular case, okay. So, that's how we have to do this particular question. So, it just depend upon these things, just depends upon your the stark splitting, and the other thing depends upon how much moment you have in the molecule, magnetic or electric moment, okay. Fine. So, these were certain questions, ठीक है, इतना ही रखते हैं आज की क्लास के लिए. जितेंद्र, हाँ पेड कोर्स भी है, बट अभी उस कोर्स को ज्वाइन करने का कोई फ़ायदा नहीं है, ठीक है, लाइक सिंस तुमने अभी तक बिल्कुल पढ़ा नहीं है. So, that course is like I teach on Unacademy Plus also. So, if you are interested, you can join the classes on Unacademy Plus. Right now a revision course is going on, so if you are interested तुम revision course को join कर सकते हो, ठीक है. So, revision course is running right now on Unacademy Plus. Also, the next course will be starting after your CSIR-NET exam, and that will be your gate specific course, okay. Your gate oriented course will be there on the Plus platform, okay. So, gate oriented course भी होगा, and that will start by your end of November, okay, by the end of November. So, from there I will be having a gate oriented course, and if you want, you can join Unacademy Plus for the longer duration if you want to prepare completely for your CSIR-NET exam. So, I teach inorganic or physical and some topics of your organic chemistry on the Unacademy platform. If you want to join, remember you can use my referral code, that is N_Huda, okay, that's my referral code, okay. How to find out the number of hyperfine splitting lines in anthracene? देखो वो सिंपल है, ठीक है. हु हैज आस्क्ड दिस? Gayatri, in anthracene what we are doing actually, first of all draw this anthracene. Okay, this is how this will be done. You have to see how many different types of hydrogens you have first of all. Okay, look for different types of hydrogen. So you have a plane of symmetry here, you have a plane of symmetry here, you have hydrogen here and hydrogen here. Okay, now you have to look for this key. Yeah, so this is what it is. Now you have to look if this hydrogen is, let's say, EPR active, so it will split, this hydrogen is going to split that, that's all, because all the hydrogens are equivalent in this case. You just have two types of hydrogen, hydrogen of type A, hydrogen of type B and type B, that's it. ठीक है, यही है. इधर भी अगर देखोगे तो ये B टाइप का है, दिस इज ऑफ टाइप A, दिस इज ऑफ टाइप A, दिस इज ऑफ टाइप B. ओके, एक और चीज़ है, सॉरी एक और है, दैट इज हाइड्रोजन ऑफ टाइप C. Okay, overall if you are looking for the molecule, if you are looking for the overall radical, okay, एक radical होना चाहिए first of all. Anthracene का radical is going to be EPR active, not anthracene itself. Now if you look for that, you have to see ki how these are going to split it. Okay, so if I am talking about this HB, so this is like the lines because of this are going to split from HA. Now is HC is going to split that line? So no, that is not going to split that line. Okay, so you are only going to get like 2Ni plus 1 use karke, since it is quite away from there, so it is not going to cause any splitting in that. Because it is 1 2 3 4 bond 5 bond away. So generally splitting वही cause कर सकते हैं जो 3 या 3 से कम bond away हो. So it will be like 2 into n की वैल्यू क्या हो जाएगी, since इसके just adjacent में कौन है, these two are equivalent, इनके adjacent में कौन है, HA और HA. ठीक है, so इस तरीके के कितने HA हैं, so we have 1 2 3 4, चारों HA equivalent हैं एक दूसरे के, yes. So all these HA are equivalent to each other, they are not different. तो कितने n कितने लेंगे, कितने टाइप के हाइड्रोजन है, दैट्स व्हाट यू हैव टू सी. सॉरी, कितने नंबर ऑफ हाइड्रोजन है, 1 2 3 नंबर ऑफ हाइड्रोजन है, सॉरी 4 नॉट 3, देयर विल बी 4. I value of each hydrogen is half and plus 1. Solve this and you will get 5 lines in this case. ठीक है, so that's what it should be. And sorry, it should also be because of this is HA and HB भी लेने होंगे, right? This is for A. B वाले भी कंसिडर करने होंगे, सो 2NIB प्लस 1 इसको भी कंसिडर करना होगा. तो B वाले आर ऑल्सो ऑफ, दिस इज B, सो B वाले आर ऑल्सो ऑफ 4 इन नंबर, सो 2 इंटू 4 इंटू हाफ एंड प्लस 1. सॉल्व कर दो, सो कितना मिलेगा, 5 इंटू 5, सो 5 इंटू 5 इज हाउ मच, 25 लाइन्स. देखो ये तब के केस में है अगर तुम्हें एंथ्रासीन का रेडिकल बोला गया, इफ इट इज गिवन कि इट्स अ एंथ्रासीन रेडिकल. अगर सिर्फ एंथ्रासीन बोल दिया गया, सो यू डोंट नो वेयर योर रेडिकल इज, एंड विथ रेजोनेंस योर रेडिकल विल रेजोनेट इन ऑल ओवर द मॉलिक्यूल. ठीक है, रेजोनेट करेगा वो पूरे मॉलिक्यूल में. इन दैट केस HC को भी कंसिडर करना पड़ेगा इफ योर रेडिकल इज गिवन टू यू. ठीक है, तो उस केस में 2NIC प्लस 1 भी आ जाएगा. So it will also get multiplied by 2 into, since HC is of two types, so 2 into half and plus 1, so it will make you 3, so into 3, so the overall answer will be 75 lines. Okay, 75 lines in your anthracene. So this is how you do. Generally कोई भी aromatic molecule हो उसमें we do like that only because there is a resonance which is possible in the molecule. ठीक है, so 75 lines should be the answer. All right, चलो टेक केयर, आई विल सी यू गाइज इन द नेक्स्ट क्लास टुमारो. ओके, कल इसी टाइम पे मिलेंगे इसी क्लास में. ठीक है, ऑन द सेम चैनल. ओके, टेक केयर, बाय बाय.